Okay, welcome to the second part, and this is all about calculating equilibrium constant. So you have here our example. For the reaction carbon monoxide plus 3 moles of hydrogen gas to form 1 mole of methane and 1 mole of water, calculate the equilibrium constant from the following equilibrium concentrations. So as stated earlier, the equilibrium constant is calculated based on the equilibrium concentrations of the substances involved. Okay, so our first step is to write the equilibrium expression. So given this chemical equation, our equilibrium expression is, so you have K sub C is equal to the product of the concentrations of the products. Okay. Let's move this one. Here we go. It divided by, so you have carbon monoxide and then you have hydrogen gas. Okay. Don't forget to write the exponent or the power to which the concentration is raised. Okay, so this is, you have here 3. Okay, so substitute to the equation. You see the concentration of your methane is, okay, let's write this properly. Okay. Let's have enough space. Okay, so you have concentration of your methane is 0.0387. Later we will discuss if we are really to consider the units. Okay, let me just finish this one. Okay, divided by the concentration of your carbon monoxide. Okay, times the concentration of the hydrogen gas. Okay, so all you have to do is to use your scientific calculator. Don't forget to multiply this number 3 times because the exponent is 3. So using your calculator, okay, you have this answer, and then we will round this off to 3 significant figures. As, or how many significant figures? Yeah, 3 significant figures, because the least number of significant figures in the given quantities is 3. So our final answer must be rounded off to 3 significant figures. Okay, shall we really consider the unit? Okay. What do you think? Okay, sometimes it's very important to consider the unit. In fact, other books really include the units of the concentration. Okay, however, the equilibrium constant is, as defined, is just a ratio. That is why in this reference the unit is not so considered. However, for the sake of since you are still beginning to understand the lesson, we will try to include the units in our future computations. Okay? Later you will see na pwedeng iba-iba ang unit ng equilibrium constant. Bakit? Kasi pwedeng iba-iba rin ang ating exponent here. So kung iba-iba ang exponent natin, then it is really possible that we will have a different units for the equilibrium constant. But even if that is the case, what is more important is not the unit but the magnitude of the equilibrium, meaning the value of the equilibrium constant. Okay, I'm going to give you another example. Okay. Say for example you have this reaction. Okay. And the concentration of dinitrogen tetroxide is 4.27 times 10 to the power of negative 2 mole per liter, and the concentration of nitrogen dioxide is 1.41 times 10 to the power of negative 2 moles or mole per liter, and this is at 25 degrees Celsius. Okay, what is the value for K sub C? Okay, I need more space here. So all you have to do is to write first the expression. K sub C is equal to the concentration of, okay, let's erase this one, this is, okay, divided by the concentration of dinitrogen tetroxide. Okay, so this is our expression. Okay, this time we will include the unit. Okay, so let's substitute. You have by the way, every time you watch the video, please always have your calculator, because you need to do the calculation also. Okay, what we are doing is we just substitute the given concentration. Okay, I forgot, we have, as what I have said, we have to consider the unit, so we have to include the unit in our computation. So what is the unit? It's mole, unit for molar concentration, mole per liter. It's -2. So we have mole per liter. Okay, so what is the result now? So don't forget to get this square of this and divide it by this number. So you can have that in your calculator. So 6. Okay, final answer must be expressed in 3 significant figures. That's the rule. Okay, just hope that you learn the rules in determining significant figures in general chemistry. And what is the unit of your equilibrium constant? Okay, for this time, it's still mole per liter. Why? Bakit hindi na-cancel yung unit natin? Because you also have to square the unit here. So when you square this one, the unit is mole squared per liter squared, and you only have here mole per liter. So cancel mole per liter, liter. So what is left is mole per liter. Okay, so that is all about calculating the equilibrium constant. Okay, next thing to consider here is this one. We have a statement here, homogeneous equilibria. What does this mean? Okay, all you have to do is to refer to the given chemical equation. If all the substances in your chemical equation exist in the same phase, then you can say that the equilibrium is homogeneous, meaning it exists in a single phase. Just like, for example, this one. So your product and reactant are all gases. So therefore, this given equilibrium is homogeneous. Okay, that is what we mean by homogeneous. Okay, now we also have here gas phase expressions. If we have K sub C, we also have K sub P. What is this one? Okay, K sub P is the equilibrium constant for homogeneous equilibrium that is composed of all gases. Okay, K sub, or in other words, K sub P expression is written using equilibrium partial pressures of reactants and products. Okay, just like for example, this one. For the reaction given above, the K sub P expression is K sub P is equal to, okay, let's increase the size, the partial pressure of the nitrogen dioxide gas raised to the power of 2 divided by the partial pressure of the dinitrogen tetroxide. Okay. Now, how is it related to K sub C, or equilibrium constant? Now, as you have observed, the way we write the expression for K sub P is just the same with how we write the expression for K sub C, except that what is considered here is not concentration. As you can see here, we are not using the symbol for concentration, this one. We use bracket to mean that we we are dealing with concentration. This time, for case of P, what we use is the partial pressure. Kasi pwede naman nating tingnan yung concentration ng gas in a certain solution using pressure. Kasi dependent kasi yung concentration ng gas sa pressure. Okay? So, how is it related to K sub C? You have here, K sub P is equal to K sub C times quantity R times T raised to the power of delta N, where delta N is the number of moles of gaseous products minus the moles of gaseous reactants. Okay? Question is, how is it derived? Okay? Let's transfer here. You have the formula. What is the formula for K sub P? So you have K, is equal to K sub C quantity RT raised to the power of delta N. This is delta N. Okay, how is it derived? Pag sa classroom pa to, I already called a volunteer. Okay. Say for example, you have this equation. Okay, papakita ko dito paano i-derive yung expression for K sub T or formula for K sub T. Okay, say for example we have this one. Okay, assuming that all of these are gases. Okay, because this K sub P is only for homogeneous equilibrium, all composed of gaseous substances. So, what is the expression for K sub P? You have K sub P is equal to, as what I have said, ganon pa rin. Kung paano natin sinulat yung expression for K sub C. So, you have partial pressure of your substance Y raised to the power of C times, let's erase this one. You have partial pressure of Z raised to the power of D. Okay, raised to the power of A raised to the power of B. Sorry, it's not B, but this is X. This is, okay, this is X. Okay? Okay, assume that each of gases, I intentionally write this one for you to remember, for you to be able to remember. Follow the ideal gas law. Okay, what is the equation for ideal gas law? You have PV is equal to nRT. I need more space. Okay, so Let's derive an expression for pressure. So P is equal to N over V times RT, wherein number of moles over volume is equal to molarity, right? With a unit mole per liter. Okay, so the concentration of a gas in mole per liter is equal to N over V. So therefore, for gas, say for example W, our expression would be partial pressure for gas W is equal to N over V is equal to the concentration of W times RT. E bakit naging ganyan? Kasi yung N over V mo is molarity. And remember that the concentration is molarity. Okay? So therefore, yung concentration ng gas W is this one. For gas W, its concentration is equal to this one. So that is why we have here for gas W, P sub W is equal to concentration of gas W times RT. Okay? Then let's try to substitute this in our equilibrium expression. Diba meron tayo noong P W raised to the power of A. Okay, where is it? This one, right? So, what is the value for that? So, this is equal to, this is equal to okay, because our PW is this one, so RT raised to the power of A. Okay? Raised to the power of A, which is just the same. If you apply the law of exponent, this is just the same as concentration of times so that is just the same. Now how about for the remaining gases? So do you have some space here? So for gas X, so partial pressure of gas X raised to the power of B is equal to the same as this one. We just replace this with X. We have concentration of gas X raised to the power of B times quantity RT raised to the power of B. Okay. How about for gas Y? So partial pressure of gas Y raised to the power of C is equal to concentration of gas Y raised to the power of C quantity RT raised to the power of C. And then for gas Z, that is still the same. Okay, raised to the power of D. You have Okay, concentration of gas Z raised to the power of D, okay, times quantity RT raised to the power of D. Okay? So, let's substitute that to our expression. So, ano ba yung expression natin? Okay, sulat ko lang ulit dito yung expression natin. Yung expression natin is K sub P. Sulat ko lang ulit dito para hindi na tayo babalik doon sa taas. Okay. Okay. I hope that you are able to follow. What's this? B. Okay? Let's review. Tama ba? Okay. And then let's substitute. Okay. Yung A natin is this one. Okay? I'm sorry, yung expression natin for PW. Let's start with Y. So you have for gas Y, you have concentration of C RT quantity C, okay, tama ba, times for Z you have concentration of gas Z raised to the power of D times quantity RT raised to the power of D. Oh, sorry. Divided by, for gas W, you have concentration of gas W raised to the power of A. Then we have what's next to W is X. Okay, tama? Okay, and then we will combine the same expression kasi meron tayong common terms dito, yung RT, right? Okay, so what will you do to the exponents if the bases are the same? So copy the common base and subtract the exponent because you are dividing. So anong mangyayari dito? So you have times concentration of divided by concentration of raised to, so ito yung sinasabi ko kanina na common, which is RT. So this is just copy here RT, raised to, raise natin yan to, diba, isusubtract natin, so you have C plus D minus A plus B. Okay? Now, if you have noticed, if you have noticed, okay, please allow me to move this. If you have noticed, your C plus D is the number of moles of gases on the right. Okay? While your A plus B is equal to the number of moles of gases on the left. In other words, since we subtract here, your C plus D minus A plus B is just equal to delta N. Okay? And if you also have noticed, this one is just the same with K sub C. Okay? Therefore, our K sub P is just equal to K sub C times quantity RT raised to the power of delta N. So this is how the expression for K sub P is derived. Okay? I hope that you were able to follow the video. Okay, all you have to do is to pause the video if you are confused with the solution, and all you have to do is to review or watch it again. Okay, so in the next video, I am going to present problems, okay, related to K sub P.